Imagine this. It's a crisp night in early July 2025, and high in the Chilean Andes, a telescope named ATLAS, part of NASA's Asteroid Terrestrial Impact Last Alert System, scans the velvet expanse of the sky. Suddenly, a faint smudge of light catches its unblinking eye. At first, it's just another blip in the cosmic haystack, a potential asteroid hurtling through the void. But as the data streams in, astronomers lean closer to their screens, hearts pounding. This isn't from our solar neighborhood. This is an intruder from the interstellar deep freeze, a wanderer from another star system, racing toward us at speeds that make our fastest rockets look like toys. They name it 3I/ATLAS, the third confirmed interstellar object ever detected, a comet born not in our sun's cradle, but in the nurseries of distant suns billions of years ago. What if I told you this glowing behemoth, captured in stunning new images from the Hubble Space Telescope just weeks ago, isn't behaving like any comet we've ever known? Its glow stretches unnaturally toward the sun, like a beacon defying the laws of solar wind and dust tails. And as it barrels past Mars in mere days, on October 3rd, 2025, at a tantalizing 18 million miles away, scientists worldwide are holding their breath. Is this a relic of ancient cosmic chaos, or something far more deliberate? A probe from intelligences we've only dreamed of? Pull up a chair, because this story isn't just about a rock from space. It's about us, our place in the universe, the shadows we cast among the stars, and the thrilling terror of finally not being alone. Stick with me as we unravel this mystery layer by layer, and by the end, I want to hear your wildest theories in the comments below. What do you think 3I/ATLAS really is? Hit that like button if you're as hooked as I am, and let's dive in. Let's start at the beginning, because every great tale needs a spark. Picture the universe as a vast, churning ocean of stars, where solar systems are like islands flinging debris into the interstellar currents. Most of that debris, bits of rock, ice, and frozen gases, drifts aimlessly for eons, too small and dim to notice. But every now and then, one of these exiles stumbles into our backyard, our solar system, offering a priceless glimpse into worlds we'll never visit. The first was Oumuamua in 2017. A cigar-shaped enigma that tumbled through like a silent scout, accelerating in ways that still baffle us today. Then came 2I/Borisov in 2019, a more traditional comet with a familiar tail, but still a messenger from afar, reminding us that our sun is just one light among trillions. And now, in the summer of 2025, along comes 3I/ATLAS, discovered on July 1st by that vigilant ATLAS telescope in Rio Hurtado, Chile. Pre-discovery images from NASA's Transiting Exoplanet Survey satellite, TESS, even caught hints of it as early as May 7th, when it was a chilly 6.4 astronomical units from the sun, 2 months before anyone knew it was there. From the moment it blinked into view, 3I/ATLAS has been rewriting the rules. At discovery, it was clocking an astonishing 137,000 miles per hour, 61 kilometers per second, faster than any previous interstellar guessed, and that's only ramping up as it hurtles inward. To put that in perspective, if you could hitch a ride on its icy hull, you'd cross from New York to Los Angeles in under a minute, the continent blurring beneath you like a fleeting dream. But this isn't a joyride, it's a high-stakes cosmic sprint. NASA's Hubble snapped its first clear portrait on July 21st, 2025, when the comet was 277 million miles from Earth, revealing a teardrop-shaped cocoon of dust enveloping a solid, icy nucleus. That nucleus, estimates as of August 20 peg it between 1,444 feet and 3.5 miles across, up to 5.6 kilometers in diameter, making it a behemoth, potentially larger than Manhattan Island itself. Imagine that, a city-sized chunk of primordial ice, glowing faintly against the star field, streaking through our system like a ghost from the galaxy's dawn. But size alone doesn't make headlines, it's the strangeness that grips us. Unlike Oumuamua, which was a reddish rocky oddity about the length of 3 football fields, or Borisov, which sported a classic comet tail of gas and dust, 3I/ATLAS is showing behaviors that whisper of secrets untold. Early observations from the Gemini South Telescope on September 4th revealed a broad coma, a hazy cloud of gas and dust surrounding its core, confirming it's a comet through through and through, yet, as it draws nearer the sun, it's brightening faster than models predicted, surging in luminosity by mid-September 2025, as if awakening from a long slumber. And that glow, Hubble's image shows it elongated 10 times longer toward the sun than perpendicular to it, a sunward stretch that's the opposite of what we see in solar system comets, where tails fan out away from our star. It's as if the dust is being pulled forward, defying the solar wind's push. Avi Loeb, the Harvard astrophysicist who's become the unlikely prophet of extraterrestrial curiosity, calls this puzzling, a feature that could hint at something engineered, like headlights on a cosmic vehicle piercing the dark. Pause for a second and let that sink in. We're not talking conspiracy theories here. This is raw data from the world's most advanced telescopes, challenging our textbooks, as 3I/ATLAS closes in on its perihelion, the closest point to the sun on October 29th, 2025 at just 1.4 AU, about 130 million miles inside Mars's orbit. We'll see if this glow erupts into a full-blown tail or something even stranger. Outbursts, fragmentation, or a steady, unnatural shine. The stakes feel personal, don't they? This comet isn't just passing through, it's forcing us to confront the fragility of our assumptions. If you're feeling that chill down your spine, drop a comment. What's the one question you'd ask this interstellar traveler if you could? Your thoughts keep this conversation alive. Let's build a community of stargazers right here. Now, let's zoom out to the journey that brought 3I/ATLAS to our doorstep. This isn't a local yokel, it's an immigrant from the Milky Way's thin disk, that bustling plain of stars where most galactic action happens. Kinematic studies suggest it's nearly 7 billion years old, older than our own solar system by a couple billion, a frozen time capsule from when the universe was half its current age. How did it get ejected? Perhaps a brutal gravitational tug from a rogue planet or a stellar close call flung it into the void, where it wandered for eons, battered by cosmic rays, its surface reddened and scarred like an ancient mariner's face. Recent papers from Michigan State University, published in August 2025, used archived TESS data to trace its faint trail back months before discovery, revealing cometary activity kicking in early, gases sublimating even at that frigid distance. It's carrying carbon dioxide-rich plumes, hints of a composition unlike anything in our Oort cloud, offering clues to how other stars birthed their worlds. Think about the loneliness of that voyage. For billions of years, silent and unseen, tumbling through the hydrogen-laced emptiness between stars. No companions, no home star's warmth, just the relentless pull of gravity's lottery. And now, by sheer cosmic chance, it finds us. But is it chance? That's where the plot thickens. 3I/ATLAS's path isn't a drunken stagger. It's a near straight hyperbolic arc with an eccentricity over 10, higher than Oumuamua's 1.2 or Borisov's 3.4, ensuring it slingshots through without orbiting, escaping back to the stars after its solar graze. As it approaches, it will flirt with our planets in a sequence that feels almost choreographed. A close shave with Mars on October 3rd at 18 million miles, then a distant wave to Earth in December from 167 million miles away, safely beyond the moon's orbit, no worries there. A Venus flyby at 60 million miles, and a final Jupiter rendezvous at 33 million miles. Astronomers at UCLA and elsewhere have crunched the numbers. The odds of this efficient planet-hopping itinerary happening randomly, less than 0.005%, 1 in 20,000. It's like winning the cosmic Powerball twice. This precision has tongues wagging in observatories from Mauna Kea to Palomar. Is it a fluke of gravity, a gravitational slingshot from some ancient black hole encounter? Or, and here's where my pulse quickens, could it be a map, a reconnaissance route optimized for data collection? Mars' rusty canyons, Earth's blue marble, Venus's hellish clouds, Jupiter's stormy bands, all sampled with minimal risk, maximum intelligence, and the timing. Perihelion hits when it's on the sun's far side from us, shrouded in glare, our ground telescopes blinded. Coincidence? Or clever camouflage? Loeb, in his September 2025 Medium posts, muses it's intentional, a shadow play to watch without being watched. As we transition from breathless discovery to this tantalizing what if, remember, science thrives on questions. If this trajectory sparks your imagination, smash that subscribe button for more deep dives into the unknown. We're just getting started. Enter Avi Loeb, the Harvard professor who's turned interstellar speculation into a respectable pursuit. Not your tinfoil hat type, Loeb's credentials are ironclad. Director of the Institute for Theory and Computation, author of bestsellers like Extraterrestrial and Interstellar, and a mind that's probed black holes and the universe's infancy for decades. When he speaks, the world listens, even if it squirms. Back in 2017, he called Oumuamua a possible light sail, alien tech skimming our system like a cosmic eavesdropper. Borisov, too mundane for his taste, but 3I/ATLAS. In a July 21st Arxiv paper co-authored with Adam Hibbard and Adam Crowell, Loeb drops the mic. Is the interstellar object 3I/ATLAS alien technology? His case builds like a thriller. The size up to 20 kilometers if brightness holds dwarfs natural interstellar wanderers. Most are pebble-sized, shredded by their journeys. The speed, 137,000 miles per hour, outpaces Voyager 1's 38,000 by a factor of 3.5. Forces that scream advanced propulsion over passive drift. That sunward glow, not a tail, but a forward beam, like a car's headlights. Loeb wrote in August, visible millions of miles out without a clear source. Perhaps an onboard power plant humming with exotic energy. And the polarization? A September 10th study shows extreme negative values, unlike any solar system comet, hinting at artificial surfaces or materials we can't yet fathom. Loeb's theory paints 3I/ATLAS as a reconnaissance probe launched millennia ago from a star system now light years dim. Why now? It aligns with humanity's tech bloom. Radio waves, nukes, space probes, perhaps tripping some distant sensor. He even floats a mind bender. At perihelion, it could break via a reverse solar Oberth maneuver, shedding speed to orbit the sun near Jupiter, lurking unseen for long-term surveillance. A small velocity tweak of 10 to 15 kilometers per second in September could zero its Mars miss, turning flyby to rendezvous. If true, this isn't a rock, it's a visitor with intent. Peaceful scout, harbinger of harvest. Loeb's words in a September CBS interview echo, "We're probably not alone. I want to figure it out. The room temperature drops as we consider this. Humanity observed. What would you do if you knew eyes from the stars were upon us? Share in the comments. Your voice adds to this global chorus." But hold on, Loeb's not without detractors, and that's the beauty of science. The fierce debate that sharpens the blade of truth. NASA's David Jewett, a comet veteran at UCLA, fired back in September 2025. It's a comet, overwhelmingly pointing to a natural body. High-res Hubble shots show a coma and tail forming, ice sublimating into that ethereal halo, just as solar heat commands. The brightness? Reflective ice crystals, standard for comets, not hull plating. And that trajectory, at 167 million miles from Earth, it's too far for detailed observation of us. Hardly efficient spying. Alternative theories abound. A fragment from a shattered exoplanet, or a Pluto-like shard of nitrogen ice, eroded into odd shapes over billions of years. ESA's planetary defense head, Richard Moisel, echoes no signs of non-natural origins. Yet even skeptics admit the anomalies. That forward glow, the polarization outlier, the improbably perfect path. As Jewett noted in CBC, it'll vanish into solar glare soon, re-emerging in December 2025, dimmer than magnitude 12, visible for a year if it doesn't shatter. No outbursts yet, but as it heats, we watch. This clash, Loeb's bold yes versus the mainstream wait, fuels the fire. It's not settled, it's alive, evolving with every telescope tick, and that's exhilarating. If you're team natural or team tech, vote with a like, and tell me why below. Let's see where the poll lands. To grasp 3I/ATLAS's gravity, we must revisit its predecessors, those harbingers that primed us for this moment. Oumuamua arrived unannounced in October 2017, spotted by Hawaii's Pan-STARRS just post-perihelion, elongated 330 to 800 feet long. It spun every 7.3 hours, brightness varying tenfold. No coma, no tail, just eerie acceleration defying gravity alone. Theories flew. Hydrogen outgassing from irradiated ice, per a 2023 study, or Loeb's light sail. It dipped to 0.25 astronomical units from the sun, then fled fled toward Pegasus, a reddish ghost reddened by cosmic rays over millions of years. 2 years later, Borisov burst in, Hawaiian named Messenger from Afar, with a textbook tale but interstellar eccentricity. Discovered August 2019, it grazed to 2 astronomical units, revealing cyanides and familiar chemistry, pristine, untouched since its birth star's youth. Less mysterious than Oumuamua, but a benchmark. Now, 3I/ ATLAS towers over both. Larger, faster, older. Where Oumuamua was a pebble, this is a boulder. Where Borisov tailed predictably, Atlas glows anomalously. Patterns emerge. All 3 timed to our detection text Dawn. Pan-stars, Atlas, yet elusive for deep study. Loeb sees coordination. Oumuamua, the scout. Borisov, the faint. Atlas, the mothership for comprehensive scans. The 8-year gaps. Time for data relay at light speed. Naturalist counter. Statistical flukes in a galaxy ejecting trillions of such objects yearly. But as Atlas's Mars date looms, just weeks away, NASA's Mars Reconnaissance Orbiter preps high-rise shots, potentially unveiling nucleus details that tip the scales. These visitors aren't random, they're textbooks from alien skies, teaching us about exoplanet formation, icy chemistries, the galaxy's building blocks. Oumuamua hinted at dry metallic worlds. Borisov, watery ones like ours. Atlas, perhaps CO2-dominated realms from the Milky Way's formative fires. Each layers our understanding, but the emotional pull, they're bridges to the other, stirring that primal awe. As we bridge from past ghosts to this present specter, ask yourself, if these are scouts, what's the fleet? Your answers and comments fuel my next video. Let's speculate together. The chemical makeup of 3I/ATLAS, with its carbon dioxide-rich plumes, suggests origins in a star system where volatile ices dominated, perhaps a young star surrounded by a disk of gas and dust, forging planets unlike our own. Scientists at Caltech, analyzing spectra from the Keck Observatory in August 2025, found traces of complex organic molecules, potential precursors to life, locked in its ices. This isn't just a comet, it's a fossil, a snapshot of a world that may have sparked life billions of years before Earth. The emotional weight hits hard. We're not just studying a rock, but peering into the nursery of another star, a place where stories like ours might have begun. Every spectrum, every image feels like flipping pages in a galactic family album, where 3I/ATLAS is a long-lost cousin, its scars and glow telling tales of cosmic upheaval and resilience. As it races toward perihelion, the question lingers, is it carrying a message, intentional or not, from a civilization that once gazed at its own alien skies? This brings us to the dark underbelly of the cosmos, the dark forest hypothesis, a philosophical gut punch born from Liu Cixin's The Three-Body Problem, but rooted in Fermi's famous lament, where is everybody? The universe teems with billions of potentially habitable worlds per Kepler and TESS data, yet silence. Why? Imagine a midnight woods, every rustle a predator's step. Shout and you invite fangs. The smart play, hide. Broadcast nothing, survive. In galactic terms, civilizations are hunters in the dark, resources scarce, expansion ruthless. Reveal your tech, radio leaks, megastructures, probes, and you paint a target. Advanced foes, eons ahead, might preemptively strike, lest you bloom into a rival. It's not malice, it's math. Survival dictates silence. Our own signals, a baby's cry in wolf country beaming since 1936's Olympics. We've been noisy for 89 years. As of 2025, our bubble expanding at light speed, now 170 light years wide. 3I/ATLAS slots in Chillingly. If Loeb's right, its probe arrived approximately 8,000 years ago, syncing with our Neolithic dawn. Agriculture, cities, writing, the spark of civilization. Did our firesides flicker across the void, triggering dispatch? In Dark Forest logic, it's recon. Assess threat level, tech curve, then decide, ally, ignore, or erase. Its path maximizes intel, minimizes exposure. Perihelion hideout, a perfect lair. Capabilities? Interstellar drive implies weapons we can't dream. Planet killers, reality benders. The resonance hits hard. Are we the newbies stumbling into a haunted house? Humanity's arc, from caves to AI, mirrors the the trigger. If Atlas lurks post-break, watching our climate wars, Mars dreams, quantum leaps, what verdict falls? Extinction as potential threat or uplift? The hypothesis terrifies because it's logical, substantiated by game theory and evolutionary biology. Species prioritize self over unknown, yet it resonates emotionally. Our isolation, the ache for connection amid stars' cold indifference. Critics dismiss, universe too big for paranoia, signals degrade, distances daunt even gods. But as Atlas nears, the forest feels darker. If this chills you like it does me, like if you've ever pondered our cosmic solitude, comment your take on the Dark Forest, utopia or trap, and subscribe for explorations of the mind-bending what-ifs that keep us up at night. Tying back to Oumuamua, the parallels scream connection. That 2017 visitor, football field long, cigar or pancake-shaped, accelerated sands thrust. 40 days post-solar flyby at 23 million miles, defying mechanics. No tail, just weird light curves, tumbling oddly. Loeb's light sail, or hydrogen vent from water-rich ice, per 2023 models. Small, stealthy, perfect scout. Atlas, 100 times bigger, follows 8 years later, adjusted from script for timeline. As if data beamed home prompted upgrade from flyby to fleet. Borisov fits less neatly. Comet classic, but timed to our growing surveys. Together, a protocol, initial ping. Oumuamua confirms life signs. Follow-up sample. Borisov baselines chemistry. Deep dive. Atlas maps all. Gaps allow light speed round trips from nearby stars. Proxima Centauri, 4.2 light years, gets reply in 8.4 years. Natural view, rare ejections cluster by chance. A TLAS from thin disk, others varied origins. But the emotional thread, these aren't rocks, they're relatives, cousins from stellar nurseries carrying DNA of lost worlds. Studying them feels like genealogy for the galaxy, stirring wonder and loss. As Atlas's CO2 plumes hint at exotic atmospheres, we wonder, did life brew there too? This scout narrative grips because it's story-shaped. Prologue, escalation, climax at perihelion. If artificial implications cascade, first contact protocols, SETI reboots, philosophical upheavals. Even if ice, it's profound. Outsiders affirm we're not unique, just one thread in the cosmic weave. Transitioning to resistance, the science community's pushback underscores rigor. Extraordinary claims demand extraordinary proof, Carl Sagan style. The backlash to Loeb crested in September 2025, with NASA debunking alien buzz in IFL Science. A natural comet, no tech signatures. High-res from Lowell and Canada, France, Hawaii telescopes show coma and 3 arcsecond tail. Classic evaporation, not engines. Brightness matches icy reflectivity, not alloys. Trajectory critiques, 167 million miles from Earth? Inefficient for spying, says Jewett. Fragments from collisions explain size speed, no need for ET engineers, yet anomalies linger, sunward elongation, polarization extremes, steady activity sans outbursts. Mainstream papers and astrophysical journal letters probe TESS archives, finding early activity but no smoking gun. The fight back humanizes science, passionate, collaborative, global. Teams from Neuer Lab to ESA share data in real time. A symphony of scopes tracking Atlas till September's end, then post-glare in December. It's democracy in action. Amateurs via ZTF contribute pre-discovery frames from June 14th. This tension, visionary versus cautious, drives progress, echoing Galileo versus the Inquisition. As we pivot to history's lens, see how Atlas crowns a legacy of rarities. 3I/ATLAS isn't just third, it's a milestone. The I for interstellar marking exiles unbound by our sun. Only 3 in human history. Oumuamua taught detection urgency, Borisov comparative anatomy, Atlas scale and anomaly. Each a treasure. Compositions reveal distant dynamos, ejections via stellar tantrums, journeys etching radiation scars. Atlas's age, 7 billion years, peers into pre-sun eras. Its ice's precision pristine snapshots of early planeticists. Unlike billions of local comets orbiting predictably, these hyperbolics pierce from outside, visible months thanks to ATLAS/Pan-STARRS vigilance. Timing's gold, months warning versus Oumuamua's post-pass miss. Global campaigns, ground, space, amateur, unleash unprecedented scrutiny. SphereX's August 7th to 15th spectra, Webb Hubble portraits, JUICE's November gaze from Jupiter. Multi-angle views from planetary passes yield 3D insights. Composition, evolution, surprises. It's a turning point. From reactive awe to proactive pursuit, humanity's cosmic literacy blooming. Emotionally, it's triumphant. Our ingenuity chasing the infinite, turning fear to knowledge. Frustration from Oumuamua's escape birthed bold countermeasures. Intercept missions to never miss again. Project Lyra, I4Eyes' brainchild since 2017, evolves for Atlas Ilk. No 2025 launch. Feasibility studies point to 2028 via Falcon Heavy SLS. Jupiter Oberth slingshots hitting 74,000 to 163,000 miles per hour sand solar dives. Multi-flybys, Venus Boost, Earth Tweak, Jupiter Kick, Pinball Precision, 22-year hauls viable. Nuclear thermal rockets eyed for rendezvous. ESA's Comet Interceptor F-Class Fast Track launches 2029 as aerial co-rider Ariane 62 from Kourou. 3 probes, ESA pair, JAXA Singleton, wait at Sun-Earth L2, 930,000 miles sunward, Halo Orbit Sentinel. Spot target via Rubin Observatory. OPS January 2025. Deploy for 3D Coma Map, 10 instruments probing untouched ices. 6-year ops, but Atlas too swift. Lesson learned for next. Latvian Seawine 3D Sims test cams, May 2025. These audacious arcs, Lyra's chases, Interceptor's ambush, embody resolve. Natural or not, we reach out. Engineering feats push bounds. Heat shields like Parker's. Trajectories dancing gravity's edge. Emotionally, it's hubris and humility. We specks on a pale blue dot. Dare grasp the stars. As Atlas fades post-perihelion, visible a year if intact, these missions promise we're ready for encores. As 3I/ATLAS approaches its October 29th perihelion, it's not just a fleeting visitor, but a catalyst for humanity's next leap. Its legacy, whether as comet or craft, will echo in our science, our stories, our souls. If natural, it enriches our cosmic catalog, a Rosetta Stone from another star's cradle, its ices and organics hinting at life's universality. If artificial, it's a paradigm shift, forcing us to rewrite philosophy, religion, policy, everything. The global response from ESA's Interceptor to amateur scope networks shows we're no longer passive stargazers, but active players, chasing truths at 74,000 miles per hour. Emotionally, it's a unifier. Billions watching the same sky, sharing the same questions. As it fades into December's dimness, visible a year if intact, 3I/ATLAS leaves us with a challenge. To keep looking, keep questioning, keep dreaming. Its path, precise yet enigmatic, mirrors our own. A journey through the unknown, guided by faint light and fierce hope. So as we close, I ask you, what story does 3I/ATLAS tell you? Is it a lone traveler, a herald of contact, or something else? Comment your theories, fears, hopes, engage, share. Like if it stirred your soul. Subscribe for the Cosmos Unfiltered. Next, we chase its tail. Until then, gaze up. The stars whisper back.